Welcome to today's Year 4 science class. We'll be having demagnetization today. Now, if you look at the screen, you notice that we have the Earth and some lines. Those lines you see are the Earth's magnetic field. Now, why would the Earth need a magnetic field? We'll learn as we go ahead. As you can see, there are other things that are coming to the Earth from the sun. Okay, we call this solar wind. The solar winds are like particles, you know, particles from the sun that go straight to the earth. Now, this this magnetic field is there for a reason. We're going to learn as we go further. So keep an open mind for that. All right. Today, what are we learning? Today, we're going to explain the meaning of demagnetization. And we're going to mention ways of demagnetization. Now, what you see here is a bar magnet and its magnetic field. This arrow here shows the magnetic field of the Earth, how they move. Whatever comes within this range of this bar magnet will be attracted by the magnet. But if it goes outside this range, like here and here, it will what? It will not attract it. It is outside it is outside the bar's magnetic field. Okay. Um, all right, so we're going to explain the meaning of demagnetization, and we're going to mention ways of demagnetization. Okay, so this is a bar magnet, okay, telling us just the way a bar magnet would have a north pole and a south pole, the same way the Earth too has a north pole and a south pole. If you look very carefully, the Earth is tilted 23.5 degrees. That's the position of the Earth, and you can see the magnetic field around the Earth, protecting the Earth from protecting the Earth. Okay, so just as the way a bar magnet has a north pole and a south pole, the Earth too has a north pole and a south pole. I remember I will learn in previous lessons that a bar magnet definitely have a north pole and a south pole. So if anything is a magnet, it definitely will have a north pole and a south pole. So if the Earth too has a magnetic field, it definitely will have a north pole and a south pole, as you can see from here. All right, what is demagnetization? Now, demagnetization is a process of removing magnetic effects from a magnet, which means the magnet loses its magnetism. Like this one you can see here, if this magnet is demagnetized, these magnetic lines will no longer be there. They will be removed automatically. So it will simply become an ordinary piece of iron. Alright, what are the ways of demagnetization? One is hammering one end of the magnet repeatedly. If I keep hammering the north pole, north pole, north pole, north pole, after some time it will lose its magnetism. Okay. Another way is dropping the magnet repeatedly. If the magnet keeps falling from your hand repeatedly, after some time it will lose its magnetism. Okay. Next is hitting the magnet. When you hit a magnet repeatedly, it will lose its magnetism. So if you apply heat to magnet, you put a magnet in a fire and you keep hitting it, what will happen? After some time, it no longer serves as a magnet. It will now become an ordinary piece of iron. The last one is passing alternate current through a magnet. If you pass alternate current through a magnet, we learned that one process of making a magnet is through the creation of solenoid, that is, passing a magnet through iron using batteries. Okay, but if you pass an alternate current through the magnet, it will lose its magnetism. Now, I asked earlier that what are the effects of magnetic field on the Earth? Now, the Earth's magnetic field serves to deflect most of the solar wind, whose charged particles would otherwise strip away the ozone layer that protects the Earth from the magnetic ultraviolet radiation. Okay, we can say this as an umbrella, protecting the ozone layer. Now, just the way we saw in the previous picture of the Earth in our onset of the Earth's magnetic field and those particles going through across. Now, what is happening there is the Earth's magnetic field is deflecting. Is okay instead of those solar wind, those particles coming through the Earth, it deflects them, it channels them to other direction, thereby protecting the Earth's ozone layer. Now, if that solar wind touches the Earth's ozone layer, it rips it rips it away, it takes it off. So we don't have any ozone layer. Hence, we're exposed to the sun ultraviolet radiation. Okay, so this is basically what happens with the Earth's magnetic field. All right, that'll be all for today. Thank you for your time and attention. Do have a wonderful day.